So one of the hardest things about astronomy is getting a really good feel for the scale of the universe, how big our solar system is, how immense our galaxy is. The universe, it's just amazing. I'm standing here in front of my retention pond that's next to our neighborhood, and if this is all you had ever seen, and then I tried to use this to describe the Grand Canyon or Horseshoe Bend or something, it'd just be very frustrating for both of us. We couldn't hardly even begin to comprehend it. Go from the retention pond to the Grand Canyon, and we'll do that in outer space, from our solar system to our galaxy to our all the way out. So stay tuned. Hi, I'm Robert Brayton, and I was asked by my church before coronavirus hit to give show my Texas Star Cave to the youth at my church and to give a little devotional. Well, things happened, and even if it hadn't happened, it rained that day, so it didn't really matter. But I just decided to go ahead and produce a video of what I call the pale blue dot. And what I want to do is give you an idea of just how absolutely huge and amazing the universe is, and then to maybe meditate a little bit on the God that created it. So if you're not a member of the youth of my church, you're welcome to come along, and but I invite all of you to stay and enjoy what I'm going to show here. I think your mind might be blown just a little bit. So the pale blue dot, that was a photograph made by the Voyager space probe, and it became a series actually by Carl Sagan he talked about. And I just want us to think some more about that pale blue dot. So this is a photo I made of Horseshoe Bend, and in the intro I talked about the size of my little canyon drainage ditch in our neighborhood, and it's really big, but it's nothing compared to the Grand Canyon, of which the Horseshoe Bend is just the tail end of the Grand Canyon. And look at this photo. I mean, it's just fantastically huge. That rock is probably at least a half mile, maybe even a mile away. I'm going to zoom in a little bit here on this little white dot coming around the left side of the bend. You see what that is? It's the wake from a boat. That's how big that is. You can't even see the boat. We're just so far away, and the Horseshoe Bend is so huge. So if all you'd ever seen in your life is the retention pond by my neighborhood, and I'm trying to describe this to you, well, that's kind of the problem that astronomers have of imagining how big the universe is. Here we are on Earth. The entire Earth is just a speck. And I want to, first of all, look at the speed of light. So I have an HHR, not that one. That one's too clean. And I drove it for the first 10 years, and I drove 186,000 miles. Well, if you know anything about speed of light, anything about physics, you know that that's how far light travels in 1 second. So it took me 10 years. It takes light 1 second to go that far. The Apollo astronauts, when they went to the moon, they were the fastest men or anybody to ever travel, and they went nearly 25,000 miles per hour, and it took them 3 days to get to the moon, and yet they were only 1.28 light seconds away. Now, they did it a lot faster than I did, but still the fastest people that have ever flown, and they got 1.28 light seconds away. A truck driver, my father was a truck driver, and a career truck driver might drive 2 or 3 million miles in their lifetime. So 10 or 15 light seconds would be the distance that they drive over their entire life. Venus, that we were going to look at had we had the star party, that was nearest elongation. That's when it's highest in the sky. And it's 400 light seconds away. 6.5 minutes is how long it takes the light to bounce off of Venus and reach my telescopes. So 6.5 light minutes, yet in his entire lifetime, my father, well, he became a photographer, but had he remained a truck driver, doubtful he would have ever gone just a fraction of that amount. Jeff Williams, Colonel Jeff Williams, is an astronaut, flew many days in space on the International Space Station, and he captured many photos, beautiful photos while he was there, and wrote a book about it. I estimated that based on the 17,000 miles an hour that they fly, that in 534 days, he probably went about 19.5 light minutes. Okay, so he went a little bit farther than the distance to Venus, but that was over a period of 534 days. The Voyager spacecraft who took that photo, I'm going to show you next, it was the fastest object ever, man-made object ever. And it was launched in 1977. It goes 320 million miles per year. And then New Horizon, that is now past Pluto, is going faster, but at the time it was the fastest object. Since 1977, it is now 17 light hours away. That's all farther it's gotten. And back in 1990, the Voyager spacecraft was so far away from the solar system, which was part of its mission, was to photograph the solar system, that they were so far away there was nothing left to photograph. And so they had one last series of photos that were made of each of the planets in our solar system. And you can see in the light ray of the sun, there's this little dot right here, this little pale blue dot. And guess what? That's planet Earth. That's us on that little pale blue dot. At that time, the Voyager craft was 3.7 billion miles away, or about 5.5 light hours. 5.5 light hours, and that's what our Earth looks like. In fact, it doesn't even fill 1 pixel. And if you look at it really close, you can see it's a little bit elongated. That's the Earth and the Moon. So, but it's amazing how huge the universe is. Even just the solar system is incomprehensibly huge. So how do we know how far away things are? Well, within our solar system, of course, we can measure stuff. We can bounce radar. And of course, you know, we've sent Voyager and New Horizons and many other space probes out there. We know exactly where these things are, down to huge, tremendous precision. So we can measure those. We can, we're still in contact with Voyager. It's 17 light hours away. We send a ping to it, and 34 hours later we get the ping back. That's how far away Voyager is. Launched in 1977. But still, it's only 17 light hours. How do we know something is a light year away, or a light, millions of light years or billions of light years? Well, we can measure the exact distance using parallax. That's a little beyond the scope of what I'm presenting now. You can look it up in your encyclopedia. But parallax, Cepheid variables, and supernova. are the way that we are able to take scientific, educated guesses at how far away things are. Parallax is pretty good measurement, but what they have done is take that parallax data on Cepheid variables, watch the Cepheid variables evolve, and then they know exactly how far away that is based on the parallax. And then they see other Cepheids in our galaxy, and then they see supernova, and they can determine how far away these Cepheids are, and then they know how far away the supernovae are based on the inverse square law. Looking at the energy coming off of the supernova, they can determine that based on their electromagnetic spectrum fingerprints and their brightness curves. So let's look at one, the Crab Nebula. This is a photo I took last year, I think. It's 6,200 light years away, and inside, right here, you can see there's a little bow shock there, and this is the neutron star, which is the remnant of the supernova that actually exploded. That neutron star is spinning so fast, 30 times a second, and they can correlate the astronomical maps made by the Chinese back in 1054. They correlate that with the nitrate ions that they find in the Antarctic, and detailed studies in the entire electromagnetic spectrum, from radio waves, microwaves, infrared, visible, ultraviolet, X-rays, the whole gamut. And also we can see motion inside of this, and because of that motion, and we know how far away it is, we can determine how fast things are moving within there. There's a lot of stuff going on, and we can correlate how fast it's moving with the Doppler shift, the red shift, and they agree. So there's a lot of science that goes on. They don't just make up a number saying, well, this is 6,200 light years away. It's based on a lot of science and a lot of correlating factors. So here's from the Arizona State University and NASA. Over a period of a few months, you can see those bow shocks coming off of the neutron star. This is from Hubble Space Telescope data. And here's an actual video of the data. So this is a loop of data. It doesn't actually pulse this way. This is a loop of data, probably the same 4 months or so, and it just keeps repeating over and over. So look at the detail here that we can see, and the motion that's going on inside of this neutron star, the shock waves from it. Here we are zooming in a little bit on it. And from that we can take just a huge amount of science, all kinds of measurements and everything, to determine the distance and what it's doing and how that star is continuing to evolve, go through its different phases. So here's a supernova I shot, captured back in 2018 in a spiral galaxy called M77, which is it's been measured to be about 47 million light years away. And here's some of the charts that they use. See, they're looking at the data in the ultraviolet bands. This is ultraviolet, the blue, the visible light, all of these, the red, the infrared, all these various things. And they're looking at how the slope of all of these correlate, how bright they are, how it's fading out, and from that they can determine exactly the brightness of this. And because it's all of this type of supernova always make the same amount of brightness, they can tell exactly, within plus or minus, about how far away it is. The farthest supernova observed was in 2005, 4.7 billion light years away, and just amazing. Here's a quasar. This is I photographed this actually just a couple weeks ago, and the quasar, the arrow is pointing to it, is believed to be 12 billion light years away. 12 billion light years away, and they can actually measure that, plus or minus, but it's it's really, really far away. I mean, you go from, it took me 10 years to drive 1 light second. It took Colonel Jeff Williams over a year and a half to go just a few light minutes. And yet here's a quasar that the light from this quasar is 12 billion light years. That's a huge distance. It's also, they determine that this particular black hole is 23 billion times more massive than our sun. And there's a disk surrounding this black hole. The quasar is a black hole. And the disk that is surrounding it has 100 trillion times more water than all the Earth's oceans. So just kind of a quick overview. So we see the distance between Earth and the Moon is 1.3 light seconds. The inner planets about 25 light minutes. The outer planets, all the way out to the Kuiper Belt, we're looking about 7.5 light hours. When you look up at the sky at night, there are just a couple exceptions, but every star that you see in the sky is within 4,000 light years. And if you live in Houston, you're lucky to see more than a couple hundred light years of all the stars that are in the sky. And yet, just our Milky Way galaxy is 100,000 light years. And then our galaxy is part of a local cluster, which is a local group which covers about 5 million. Local cluster is about 50 million light years. That includes the Andromeda galaxy and the Triangulum galaxy. And then we go out another billion light years. Our observable universe is more than 10 million light years. Like I say, that one star or quasar that we saw is 12 billion. I didn't mean million, billion light years. And I appreciate Andrew Z. Colvin making that little chart for us. That's really helpful. So, as big as the universe is, and as huge and the amount of energy that's in the universe, it stretches the imagination to think that there is a being that created all that. And it further stretches the imagination that, why would he care about me? I mean, what are we compared to the entire universe, billions of light years? But we see some things that are extremely difficult to explain without an intelligent designer. The fine-tuning of the physics, and not just the physics, but our solar system and the Earth itself. The amount of magnetism in the Earth, the moon stirs up the oceans, and I could go on and on about that. That's a whole nother video one day, maybe. Strong evidence of purpose and design, and the fact that we have a free will and curiosity, and that we can use language and technology. It's just amazing, all the things. So let's take a look at that a little closer. First of all, what we know about the universe is also a reflection of the attributes of God. I don't like to get hot or cold, so guess what? I have an air conditioner in my star cave, and I have insulation on all the walls, and I kind of seal things up wherever I can because I don't like to be cold. Well, when an engineer or someone designs something, they put part of their own personality and part of their own attributes into that design. So what can we see from God's design? Well, we see his eternality. The Romans 1:20, the invisible attributes, namely his eternal power and divine nature, have been clearly perceived since the creation and the things that have been made. So we see that, and we can get a better feel for who God is. You know, I think a lot of people these days have an idea of who God is, and to be honest with you, it's really small, okay? And if nothing else, hopefully just thinking about the size of not just our solar system, but our galaxy and our universe, and just trying to get 1% of 1% of how unbelievably huge that is, that maybe your God will get a little bigger, okay? His omnipresence, you know, these are, he is outside his creation, yet where shall I flee from your presence? David asks in Psalm 139. His omniscience, that, you know, what man shows God his counsel? Who did he consult? Who made him understand? God knows. And his omnipotence. By faith we understand that the universe was created by the Word of God, so that which is seen was not made out of things that are visible. So when it comes to science and philosophy or theology, we should not expect to find God in science. I mean, we find things that would be consistent with a creator. We see design, we see other things. But there's nothing in science that we would necessarily expect to say, there's God. And I think that a lot of people are looking for that silver bullet that just really doesn't exist. For one thing, if God were obvious, then in the God of the Bible, then there wouldn't be any faith, and yet it's through faith that we come to God. So I'm getting ahead of myself a little bit here, but one of my favorite verses, of course, is Psalm 19:1. The heavens declare the glory of God, and the sky above proclaims his handiwork. But God would also be truthful. So, as a young earth creationist, in our church, we believe that the earth is somewhere around 6,000 to 10,000 years old. Well, if the earth is 6,000 to 10,000 years old, and light is millions of light years away, now, a light year is not a measurement of time, it's a measurement of distance, yet it strongly implies time, right? I mean, you know, let's be realistic here. So how can we see objects that are clearly farther than 6,000 years away? Light years away, rather. How can the universe appear to be created or not created on the person's worldview? Charles Darwin said it's mere rubbish thinking at the present of the origin of life. One might as well think of the origin of matter. You know, Charles Darwin obviously was an atheist, but he looked at the same universe and said, no God. I look at that universe and say, God's got his handwriting all over it. So how is it that can happen? Well, before we get too far along, I want to assuage any thoughts about, well, maybe they're just, you know, making all these too many light years up and all that. Well, Danny Faulkner, who is with Answers in Genesis, he's also the University of South Carolina Lancaster professor of astronomy and lots of other things. He's written a few articles there. You can see the URL if you want to go do more research on that. But he says, yeah, we can have confidence that the universe really is as large as astronomers claim. Russell Humphreys, I'm going to talk more about him, says the distances are immense, measured in billions of light years. He was with Sandia National Laboratories and is now associated with the Institute for Creation Research, as am I, on a volunteer basis. And what about Bible teachers? John MacArthur says, if the universe is no more than 10,000 years old, how can we see light that theoretically took millions of years to get to us? Again, Joe Martin, who wrote the book The Evolution of a Creationist, he said in his book that many scientists, evolutionists, and creationists are studying Russell Humphrey's book, Starlight in Time. And he says this book is a must. And I agree. It's a good one. It's kind of the beginning salvo of several books that have been written. So then how can we see the distant objects? If the universe, as I believe the Earth at least, was created around 6,000 to 10,000 years ago, it could be more, but definitely not millions of years. So what Danny Faulkner says is, well, the creation week was a week of miracles. When God created the animals, they created them out of the dust, and they just came out of the dust. Well, that's a miracle. And everything that God created was ready-made, ready to serve the purpose for which He created it. Well, the stars and the planets were created for signs and seasons. So when man showed up on day 6, Adam and Eve, at that point, we need to have stars and sun and moon, not to mention, keeping things growing. And so Danny Faulkner, his assertion is, well, it needed to be so, and so God made it so. And that's okay. I don't have a problem with that. Other people that are maybe atheists, they might have a little more of a problem with that. And I think that's where Russell Humphrey's book shines. So another explanation is light travels many times faster than we think. Even the Big Bang, during the inflation, light traveled much faster than what we measure today. So that's a possibility. And then God created the information in light. So that video that I showed you of the pulsing shock waves in M1, that was just a picture show for us to watch, that God created in the light that's traveling to us. I don't believe that for a minute. Okay, I don't get that one. So what Russell Humphreys and others talk about is something called white hole cosmology, where using relativity, what we understand of relativity today, there's a thing called a white hole in addition to a black hole. It's just kind of a white hole or a black hole is turning itself inside out rather than pulling everything in. It's ejecting. So this concept is that God slowed down the time using relativity on day 4 while billions of years of physical processes transpired in the rest of the universe. And that's what I'm going to talk about now. So before I get into that, I want to just take a little side note here, talking about, because the white hole cosmology is based on water. So let's talk about a little bit about water. The Orion Nebula that we see pictured here is a cloud of gas. It's not water, it's just a cloud of gas that is hydrogen gas and oxygen gas. Of course, those are the two things that make up water. Now, this is not water, it's just gas, but it's 24 light years across. It's just an immense cloud of gas. So I just kind of want to open your mind a little bit to think about how there can be unbelievably huge objects in the universe. And then think back to that quasar that we talked about earlier, the one that I photographed is 12 billion, believed to be 12 billion light years away. Well, that disk that has 100 trillion times the amount of water in our oceans. Well, if you do the math on that, it's 3.5 times 10 to the 28th gallons of water. Just an unbelievably huge amount of water. And that's in a disk that is orbiting. It's too far away to know exactly what it's doing, but they definitely know that there's water, liquid water, associated with this black hole. So let's delve into Russell Humphrey's white hole. So it's the whole universe. This is Russell Humphrey's white hole cosmology. The whole universe started as a 1 light year ball of liquid water. And then, well, as you can imagine, with that much mass, black holes aren't far behind. So black hole begins, which then God creates from that a white hole, and then extracts the entirety of the universe from that white hole. That's the idea, okay? So 4 days pass while the earth is being created. So we look at Genesis 1:14. God said, "Let there be lights in the expanse of heaven." And God said, "Set them in the expanse of heaven to give light on the earth." So that's the idea here. Of course, obviously you're going to get a lot more than I can cover right here in Starlight and Time by Dr. Russell Humphreys. So the first thing when I saw that, it's like, wait a minute, let me do the math here. Because, obviously a 1 light year, which I can't even really imagine, but just trying to imagine a 1 light year ball of water, is there even enough matter there to create the universe from it? Well, guess what? If we do the math, 4/3 pi r cubed is a volume of 3.5 times 10 to the 57th cubic centimeters of water. And by definition, water has a density of 1. So it is also 3.5 times 10 to the 57th grams. And sure enough, the observable universe is estimated to be 1.5 times 10 to the 56 grams. So that number is less than the amount of matter in the actual 1 light year ball of water. So, okay, the math works out. So the white hole cosmology, going back to the deep, Genesis 1, in the beginning God created the heavens, the earth. The earth was without form and void, and darkness was over the face of the deep. And that's where Humphreys believes it became a black hole. So this intense light was everywhere inside the black hole, and then on day 4 it collapsed and became the white hole, which caused the rapid inflationary expansion of space and created the universe, all the matter. So as everything's being ejected out of this white hole, God is creating each and every object. So he's creating the galaxies, the stars, the planets, everything that's being created out of that. So in verse 6, God said, "Let there be expanse in the midst of the waters, and let it separate the waters from the waters." And that's how the black hole, the white hole, God was able to do that with that. So he separated the waters under the expanse from the waters that were above the expanse, and it was so. And he called the expanse heaven. And there was evening and morning of the second day. So the waters were differentiated above and below, and of course, as you begin to expand, Boyle's law is going to cause things to cool down, is the law that follows how things cool as they become less dense. So that then is above the waters and below the waters. So when it reached about 3,000 Kelvin, the atoms formed and the expanse became transparent, and that's when we get the light. and it continued uniformly until it reached what we now see is that 2.76 degrees Kelvin, almost absolute zero, but not quite. So it's stretched out just an amazing amount. So what was a 1 light year ball of water is now billions of light years of mostly empty space. Incredibly amount of empty space. We see in Isaiah 40:22, God stretches out the heavens like a curtain. So we see some evidence of this cosmology throughout the Bible. So Answers in Genesis quoted the Biblical Creation Society and said, the time dilation effects of relativity theory permit billions of years worth of physical processes to take place in the distant cosmos. The stars and the galaxies formed and the time elapsed so that the light was able to travel to every corner of the universe. And thus, Adam and Eve were able to see the signs and seasons, the stars, the moon, and the sun, and the planets, all on day 6. They were all ready to go, just as they were required. So that's just one quotation. In Common Science, there was an article written in New Astronomy in February 2012. These two gentlemen wrote a paper where they suggest the emergence of a white hole is like the Big Bang. Now, this is certainly not proof for white hole cosmology. I'm just saying that even the secular scientists would say that a white hole would behave in such a way that when it was all done, it would look like a Big Bang. So, one thing that atheists do have heartburn about is that whether we are exactly or even near anywhere the center of the universe, because that would show that we're in a special place, and the probability of us being anywhere near the center of the universe when the universe itself is billions of light years is highly, highly improbable and would suggest that we were created. But George Ellis quoted in Scientific American, I want to bring out into the open the fact that we are using philosophical criteria in choosing our cosmological models, meaning that we are not in the center of the universe. And it really is a question of philosophy, or I would even say theology. Richard Feynman, back in 1937, said, I suspect the assumption of uniformity in the universe reflected prejudice born of a sequence of overthrows of geocentric ideas. So part of what had happened in science is through Darwinism and other cosmological advances, they were able to throw off once and for all the idea that the Earth is anywhere near the center of the universe. And then Feynman went on to say, to avoid embarrassment, we cling on to the hypothesis of uniformity. Creation Wiki, according to the white hole cosmology, so they say this is solution to distant starlight problem that is both scientifically and biblically sound. Main problem is it's difficult to test. Well, yeah. So, and the Big Bang is not quite as subtle science as some might have you believe. The cosmic microwave background is very, very uniform, which is very difficult to explain. And there's nothing about the Big Bang that is easy to explain how stars and galaxies form. Just as the cosmological, the physics are so fine-tuned, well, so is the flatness. See, we are in a three-dimensional universe that is believed to be part of a fourth-dimensional space, and that's the universe then can be curved in on itself or curved away from itself, or it could be perfectly flat. And again, the number of ways it can be curved are so much greater than being totally flat that we would not ever expect it to be exactly flat. And also it makes the universe very difficult to reset itself when it's this flat. The baryon asymmetry is the fact that the Big Bang would have created as much antimatter as it did matter, yet everywhere we look in the universe, we pretty much only see matter. Now, of course, the white hole has the exact same problem. Pulling all that energy out of the white hole very well may have created antimatter, but God was in control. Dark matter is, it's a reason for saying, or another way of saying there's not enough gravity. So, I mean, there's some really big problems. Even the Wikipedia Big Bang article says that one of the common misconceptions is that the Big Bang model fully explains the origin of the universe, but it does not describe how energy, time, and space was caused, but just the emergence of the present universe from an ultra-dense, high-temperature initial state, which we would also see in the white hole cosmology, by the way. So really, there's a lot of philosophy going on in science in the Big Bang model. And then one thing that keeps a lot of physicists up late at night is the cosmological constant. I don't have time to explain it right now, but basically there's we can measure things in the laboratory, and from those measurements, we would then extrapolate that to the universe and say, and this is how the universe should be. And there's a cosmological constant that translates from the subatomic particles that we examine in the laboratory to the universe that we see in our telescopes. Well, the difference between those two is 120 orders of magnitude. In other words, the difference between what we think it should be and what we actually see is 1 followed by 120 zeros. American Journal of Physics called it the largest discrepancy between theory and experiment in all of science, and the worst theoretical prediction in the history of physics. It was in a book published by Cambridge University. So I want to be sure you understand, white hole hypothesis is just that. It's a theory. It is not theology. It is a way that God could have caused the universe to be formed. But like Diane Faulkner says, it was a week of miracles. God needed for it to happen. He made it happen. This is just one way that he might have made it happen. I am encouraged by knowing that there is a scientific hypothesis that is consistent with Scripture. That's really the main takeaway for me. So here we have these billions of light years, trillions of galaxies, unfathomable energy and mass, intricate design and purpose and profound beauty. Where did all that come from? Bible says in 6 days God created the heavens and the earth, and he did it for mankind. God blessed them and said to them, "Be fruitful and multiply and fill the earth and subdue it." He did it for his glory. The heavens declare the glory of God, and the sky above proclaims his handiwork. And he did it for love. The Genesis 1 really is a love story. God created, just lavished this whole universe on us to show us his might, his love, and his care for us. In 6 days, he lovingly, intricately crafted and ultimately declared very good his creation. And then he makes man, husband and wife, puts them in a beautiful garden, sustains their every need, endows them with gold and jewels, and only requires that they tend the garden and raise a family. How hard is it? But he also gave them free will, which is really hard to explain if you don't believe in God, because where does free will come from if we're just a collection of molecules? But we're not. We have a mind that goes beyond just the molecules that make up our body. And that free will, because we had free will, that meant that we could also not do what God wanted us to do. And sure enough, we did. There's a saying that if God were any more apparent, belief in him could not be called free will. I mean, God lavished this whole universe on us. He's given us everything that we need to sustain us. And if he did anything else, I mean, it would be hard to say that God's not forcing us into it. But in spite of all his might, in spite of his kindness, we choose to sin against our Creator. And there's no excuse, no justification, no redemption. Only he can save us. We have sinned against the Creator that created that quasar 12 billion light years away. We have sinned against him. There's no turning back. We didn't do what he required of us because he gave us a free will. But with that free will, he also gave us redemption. He himself became death for us. We only need to receive that through faith. There's no sign, you can't get out your slide rule and measure that God is there and, hey, I know, and there's no doubt whatsoever. No, there will be doubt. And with that doubt, there has to be faith that overcomes that doubt. We turn from our sin, cherish the gift that God has given us of salvation, to be forgiven of our trespasses against him. God so loved the world that he gave his only Son, that whosoever believes in him should not perish, but have eternal life. And that's why we have the universe, for God to show his glory, and somehow that involves us. I don't know why. I mean, we are pretty amazing. You know, I've studied the DNA of our bodies and how that whole biological molecular machine works, and man, that is a mind above all minds, to fine-tune the parameters of the universe so that carbon can even exist as an element, and then that you can make DNA from it, and that DNA can replicate inside a living cell, but it has to be given that spark of life. And we can only gain our physical life through God, and we can only regain our spiritual life through God. So you can get more information. You can go to ICR.org, Answers in Genesis, creation.com, or of course, our church, gcbiblechurch.org. We would love to have you come visit. The book, Starlight in Time. And along with that, then Alex Williams and John Harnett have written Dismantling the Big Bang, and John Harnett went on to write updated Starlight in Time. And of course, John MacArthur wrote The Battle for the Beginning. Some of that is a little dated in there. I'm sure he'll come out with a revision one day. The Work of His Hands, Jeffrey Williams, Mere Christianity by C.S. Lewis. There are so many resources out there that you should really take advantage of that while you still can. So I would say that if somebody tells you they have proof for God, I would say take that with a grain of salt. And if someone says they have proof that God does not exist, get a bigger grain, okay? The anthropic principle, that's what the cosmology is based on today. That the universe appears to be designed and specifically fine-tuned for life is no more scientific than because God. So I hope this helps you in your walk with God and really opens your mind to just how great our God truly is. So keep looking up.